Today we're looking at scatter plots and predictions, okay? And we're going to start with this idea of trend lines, which we mentioned that very first day when we did that small project. So when scatter plots demonstrate a linear relationship, a trend line can be used to show the general pattern of the data. Okay? So this line is is a straight line that should be as close as possible to the what? Center of the data in the scatter plot. And what we mean by that is centered in the data. Okay, centered around the data. Okay, so we're going to look at these 1 through 4. Which one of these, number 1, is that a good or a bad fit for the data? Very bad. So we're going to write very bad. Because the data doesn't even go that direction, right? The data doesn't even go that way, it goes that way. So that blue line would be a better fit for the data than the red one there, right? That would be a better fit than the black one, okay? Okay, now what about number 2? That's a really good fit, yeah, so that's good fit. And then number 3, is that good or not good? Yeah, because it should be nope, that's not what I want.
What did you do?
Sorry. Okay, what it should do is something like that. Okay, so the black line is a little bit too high in this case. And then the last one, it's also not great because the line should be more centered. That's not good either. There we go. So that bottom one over here is also not, or number 4 is also not good, because the line should be more centered. Okay, so that's the basic idea of trend line. Okay, so trend line is a linear value or a linear graph. So that means it's going to be always a line. Okay, it will never be some sort of curved, right? A trend line that's curved wouldn't be linear. That would be some other function. Okay. So what is the describe the association of the data for number 5? What kind of association is that?
Positive.
Okay, so how do we know that that's a positive association? Because as one value increases, the other value is also increasing. So remember, that's the definition for positive association, is that both directions are increasing. Okay, it says sketch a trend line. So where do you think the trend line should start? Okay, you want to start it at 13, okay? And then should it kind of go up and to the right or down and to the left, or?
Up and to the right.
Okay, something like that. Now, I have no way of drawing it perfectly. Okay, now, I don't like that doesn't auto set. Okay, now the last question here is, Mila wants to predict the value of y when x equals 10. So trend lines are useful because trend lines can allow us to make predictions. So what I want you to do is I want you to draw a line at x equal 10 all the way up. And it would cross the trend line somewhere up here. So the reason I put a ton of little dots there is because it really could be anywhere in this area. Okay? And so what I want us to understand is this is not necessarily going to give us the correct answer. It's going to give us a what? A guess, a prediction. Okay, it's going to give us a guess or a prediction. So at 10, what is the prediction then for y value? If I just kind of looked at where these dots were, be pretty close to 45. So why is a trend line helpful for looking at this? Yeah, it gives us something to look at. It gives us an exact thing to look at. Even though the answer isn't exact, the line itself does give us an exact value that we can look at. But that value, remember, is just a prediction. Okay, so let's look at number 6. So before I predict the value, I'm going to draw a line. So I think it should probably go something like that. Okay. Now, what is this thing over here called on the outside?
An outlier?
An outlier. So in this case, the data does have an outlier. But it wants to know, predict the y value when x is 7. So I'm going to, after I draw my line, I'm going to go to 7 and draw up. And then where it crosses, go over. Okay, once again, if your line isn't the exact same place as mine, we may not get the exact same answer. Okay, so where does it cross between 40 and 50? So what's a good value for that, Brylan? You can pick anything between 40 and 50. Okay, 42. So if you look at it, it looks slightly on the lower end of the 40 to 50 range, so 42. So depending on how well you draw your line, or how straight you draw your line, or if your line is off by a little bit, your answers on these questions will be slightly different from each other. No one should have the exact same answers because the lines are not going to be drawn the same for every single person. Now, if we were doing this on a computer, the answers should be the same. But since we're not, they won't be. Okay, so same thing. If we draw a line, it should probably go from here to here, or that one doesn't look great, so I'll try again. Maybe let's move it just a little bit. Okay, so that looks okay. So this one says predict the value of x when y is 5. So what should I do? This time, which value was given? 10, but it's what kind of value? Y. So I'm not going to start with the x values, I'm going to start with the y values. So I draw a line over, and then I look at where they cross. Okay. And so there's an argument here. You could have like a range of maybe between 9 and 11. Right? Some people might put 9, some people might put 10, some people might put 11. So since it didn't say we couldn't use decimals, I'm going to do 9.8. Once again, it depends on where your yellow line is. Okay? If your yellow line was higher, then this value might be a lower value. If your yellow line was lower, it might be a higher value. Yeah?
Sorry, did you say it has to be the exact decimal? we got?
I'm sorry, did I say what?
Did we say that we have to write it? Did you say that we have to keep it as a decimal, or can we write it up or down?
No, I said that it doesn't say that you can't use a decimal, so I was picking a decimal that time.
Okay.
Okay, once again, this data has a what? Landon, this data has a what? An outlier. Okay. And then once again, we'll put some, it looks okay. And it wants to know when y equals 30. So I didn't go far enough. When I did my original line there, so I'll do another one. Okay. So it says predict the value of y when x is 30. So which way am I gonna, which one am I gonna go to first? A y or x value? X. So I'm gonna go to 30 and I'm gonna draw up. Okay. And so I've got it crossing somewhere over here. And these are counting by 25s. So 25, 50, 75, 100. So it's somewhere between 75 and 100. It's closer to 100, I think, than 75. So I might say something like 90 or 91. And you can see how we're going to get different results, right? Because I'm just guessing a number between 75 and 100, yes.
Is there a wrong answer?
There is a wrong answer, right? If you put 25, that very clearly is a wrong answer. Do you know what I mean? It just needs to be within a range here that matches your line. Like if your line looked like that, if your line looked like the black line, then your guess would be somewhere more around 75. Okay? But if your line did that above mine, your guess might be closer to 100. Okay? But there's no way from this data that you can get a line that looks like this. Right? That's a bad fit. So there's no way you could get 25 as an answer unless you just had a really, really terrible line. So there are wrong answers, but there's not one right answer. Okay, let's go to the back, and I want you to do number 9 on your own. Give you guys maybe a minute and a half, 2 minutes. If you finish that one, go ahead and go to the next one. Okay, what should I do first? Yeah, I'd probably draw a line. That might be helpful. Okay. And then A says, predict the age of a polar bear that weighs 50 pounds. So where am I going to draw my line? On the X or the Y axis? Y, because that is weight. So I'm going to go to 50 and draw a line over. Now, where does that cross my blue line? Right here. which is really close to which age and month? 5. Now, like I said, it could probably fluctuate some depending on your line. So between 4 and 6 is what I would accept, but 4 and 6 themselves are probably a little bit too far, but for the sake of practice, it's between 4 and 6. Okay, now the next question, B, says, what about 10-month-old bear? So this time, what would I have to do? Start at 10, and what value would that be close to? Close to what? 100. Okay, now C is a little bit more complicated. A polar bear weighs 42 pounds, and Jamie estimates the bear is between 4 and 5 months old. Is his estimation reasonable? Why or why not?
Yes.
Why?
Because if you have 42 pounds, it crosses over at about the 45 number, or like it connects right there on the line.
Because what connects?
The dot and the trend line.
Okay, the trend line matches at 4 to 5. Okay, so basically what we're doing is we're saying that between 4 and 5, the values are between these two here. Okay, so basically we're going the opposite. We're saying between 4 and 5, the values are between 40 and 50, so 42 is reasonable to say that. Does that make sense? Okay. So look at number 10, same thing. Okay, so do number 10. Okay, so A for number 10 says Gregory has 45% of his popcorn remaining. Predict the percentage of the movie that he has watched. Okay, so which one are we looking at first, the Y or X axis? Y, popcorn remaining. So where's 45%? Okay, right there. And so where does that cross down here? About 35. Okay, it crosses between 30 and 40. Now, once again, it depends on what your line looks like, right? Your line might be shifted a little bit. So as long as I can see the line and where they match up down here, your answer could be right. Later on, like I said with the computer, this will be easier to do. So 35. Okay, 35. Brianna watches 60% of the movie. Predict the percentage of popcorn remaining for her. So where's 60% of the movie? It's like way down here. So what's a good guess then for how much popcorn is left for Brianna? I'm sorry? Like 5 or maybe even 3? Because once again it depends on your graph, right? If your graph went through the line up here, then it would be 10. Okay? I'm not saying your answer is wrong. I'm just saying that based on the graph that I have, 5 would be a better answer. Erica has watched 20% of the movie, and her brother bets that only 30% of her popcorn is remaining. Is his prediction true or untrue?
No.
No. Why? No, because at 20%, 20%'s here. How much popcorn is left?
About like 80%.
Yeah, it could be 70 to 80%.
Yeah.
So about 70 to 80% of the popcorn is left. Yeah. Okay. Let's look at number 11. Okay. Try number 11.
That's all. That's all I came to do. Just give you the note.
So the graph below shows the cost of several homes in Ashton's hometown based on the number of years since 95. Ashton sketched a linear trend line shown and predicts that if he purchased a home in 2002, it would likely have cost him $375,000. Do you agree with this?
Yes.
Well, where would I draw a line? He says 2002, and this is year 7, good. And does that match around 375?
Yeah.
Yes. So, yes. Because at 7, the value is close to 375. Okay.